can see on the screen, so this is in Annapolis. I don't know if you know about this.
The Naval Academy, or?
Yeah, and they had all these towers, and the origins. They say when they went in service, but that doesn't really mean that they were not already there and being used in some capacity, which I think they were, because I kept going back and trying to find the origins of this type of communication, and I'll show you why in a little bit. But when I began digging, I would find things like this that were seemingly always there. It was something that was just ever present, really. It was always there. So I can show you. They have these documentaries, and I don't know if you've seen too many of these, but I want to play a few of these little clips. A lot of them are from AT&T, but it has all of the kinds of hoaxy production, even the same like voiceover guys as some of these space program propaganda shows that they did. And
it seems like they use a lot of the same announcers on all of them. You're right.
Mm-hmm. I even found one that had Disney art. Like, it seemed like straight up Disney, just like a lot of the old fake space stuff. And so I'll play this, and let's see. And it starts off with the globe and fake space anyway.
Gotta love it.
Yeah. So they're talking about long distance communication. So it just starts off with as hoaxy as you can get, true boardroom. And
I believe in the future, wires will unite different cities, and a man in one part of the country may communicate with another in a distant place.
When Alexander Graham Bell wrote those words in 1878, he foreshadowed the basic...
So right there, they said 1878. You heard that, right?
Yep, I did.
And did you know that in the Civil War, they had set up telegraph wires all down from the front all the way up to Washington, D.C.? When Sherman drove south. Did you know that?
No, I didn't know it was that extensive. I knew they had them set up, but I had no idea, to what end or, to what depth.
Yeah, they had telegraph wires, and that's one of the first things that got me onto this when I saw that that was declassified not all that long ago. I would say in the 70s or 80s or maybe even the 90s, they declassified some of these photos and different things about that communication. And when I saw it, they had really high towers built. And I thought, well, if you're running a telegraph wire, why would you have to build a 300-foot? And so that got me thinking, and I was thinking more about atmospheric electricity. And I think I was correct that building it to 290 feet, I think you maximize your voltage potential from atmospheric energy, which we see in the buildings a lot, and we see in the power lines around us too. And that may, I thought, have driven the telegraph wires. But then there was this idea of the communication itself, and so how could Alexander Graham Bell speak the way he did in 1878, saying to be able to communicate from one part of the country to another? They were already doing it.
Exactly. Well, it's supposedly, now this is also something that kind of goes right along with that, is I'm sure you are familiar with the Carrington event that allegedly took place in 1859, right? So they attribute that there was this big coronal mass ejection. They say basically that was so intense it was like an X10 or greater than an X10 class flare, and it was so intense that it burned out telegraph offices and, set the poles and stuff like that on fire. And they actually called it the Carrington event. The problem is that Carrington never wrote about it. I mean, it was like this was something that was attributed to him, as it was some sort of discovery of his, after the fact. Because when you go back and you actually look at the documentation around that time, and he never even wrote about it. And yet this is one of the most famous things you've ever heard about the Carrington, Carrington himself. So, yeah, I just thought that was kind of crazy. But, supposedly September of 1859 that happened.
Yeah. And it's not well documented like everything. I mean, the documents don't even start until about 1850, but even that being after 1850, things aren't very well documented at all. Yeah.
Exactly.
Yeah.
Yeah.
But the incongruities that I don't think another human being in the world may have noticed it, and I don't know how. You make your own timeline and keep track of things of when would they know about something existing, and it doesn't ever seem to really add up. They try to make it seem like people are so hard scrabble, rough, hokey, just simpletons with two books, the almanac and the Bible, and nothing else. They don't know anything else, and all the way up until sometime in around 1900 or something like that. It's kind of crazy.
At the time, the telephone itself was only 2 years old. A man in one part of the country may communicate with another in a distant place. First, research had to meet the challenge of getting man's voice clearly to that distant place. The problem of transmission. It was, of course, the miracle of the telephone that made possible the transmission of speech by transforming the speaker's voice into electrical waves.
And so this really got me. You see these buildings, and you see this. They've even got the antenna right there. You know what I'm talking about?
Yeah, I see that.
and then this. Oh, it's a weather vane. Oh, maybe. Oh, it could be a lightning rod. I don't know. Maybe. And then these metal spiky things up here to keep birds off. I don't know.
Yeah,
maybe
purely decorative, obviously.
decorative. Right? Yeah. That's they just pioneers spend all their time doing wrought iron and things like that, welding and everything to make that stuff. And so they have it right in your face. And it's this thing that, we see it in the flat earth research, that they purposely put something right in your face, showing you the truth in plain sight. Because I don't know if it's just duper's delight, but it seems to be a mind control tactic to inoculate you against the truth by getting you in a suggestive state and then presenting something as the truth. It's very important for them to include the actual truth mischaracterized or obfuscated along with it.
Exactly. And that seems to be a rule that they have to play by. And, I've mentioned that several times. It's like, for whatever reason, no matter how it's presented, the truth has to be presented, whether it's in the form of comedy, ridicule, whatever. It's out there, and because for those that are looking for it, have to be able to find it. And that seems to be a rule that they conform to, for whatever reason. Apparently there are rules on that side of the fence, and this could go into, law of free will, universal free will and stuff like that. I don't know, but it does seem to be the case that, they have to show you what they're doing. They have to, and they do.
Yeah. Yeah. You can see it with everything going on now too, with the contradictions. Yeah. So,
hello. To be changed back to sound waves at the other end of the wire. Hello. But over long distances, the voice gradually faded away.
How are you? How are you?
Despite that fact, by 1912, a man in New York could talk into a telephone.
Talk louder.
And with the aid of various devices, he could be heard more or less distinctly in Denver.
Talk louder.
So there they show the elevated power lines, and that is a key. That's a clue again, like we just said with the truth in plain sight. The only reason they elevate them is they get voltage boost from atmospheric electricity, I believe, and I found evidence to support officially too. The thing I don't understand about it is that it is direct current. It would be direct current, and so for alternating current transmissions, I don't know how effective that would be, but
yeah, it would be very lossy as with direct current. But the thing is that maybe, I'm sure it holds true as well with direct current, that the higher the voltage potential that you have, it seems like the less lossy it becomes over the lines. So maybe they figured out a way to enhance that DC, high voltage DC, into amplifying the signal.
Yeah.
But
well, I think just the fact of it being elevated, the atmospheric energy is boosting every step along the line, and so the boost that they get is perfectly consistent if they keep the elevation about the same. And so the loss doesn't really factor in as long as they match up the voltage boost by the ground height elevation.
yeah.
At least that's what I think. But I found documents from phone companies that support that. And so,
yeah, and yet, I can tell you from working a little bit of time in a telco office that, these lines, these twisted pair of lines, do terminate, and they do have balanced, like 300 and 600 ohm input impedance line amplifiers that obviously they use. But again, this is something that is fairly new technology. I don't know how they did it, hundreds of years ago. But they do have those line amplifiers that now equalize the line levels and, kind of standardize everything. But, you don't really get a lot of history on it. You just understand how these things work. But the history, I'm sure, like everything else, is obfuscated and kept from us.
Yeah. In fact, what they present here is absolutely comical. If you want to see it, I mean, it's pretty funny. But they do this play act with these like a recreation. Basically, the guy in charge is standing, saying, "Men, we gotta make it work better," and it's really nonsensical. Like,
I know, I love these. They're so hokey.
Yeah, if you want to see it, I mean, this is one of the best ones I've ever seen, where the guy's just telling them to do it. Do it. Make it happen. You can have 5. I want 5 conversations going on at the same time. And then the
multiplexing was born.
The first transcontinental telephone line made front page news. But there were still telephone men who knew the job had only started.
It's a great accomplishment. Nobody can doubt that. All of you men have talked over this so-called transcontinental line just as I have. By the time my voice hits Frisco, I sound like Jenny Lind. Or vice versa. I only wish it was funnier.
One of the really rough problems is those vacuum tube amplifiers. Each one we use on the line adds its own distortion to the content.
You're right. The amplifiers are a problem. By the way, do any of you men know what the word telephone really means? It's from 2 Greek words, meaning far and sound. And I would say that if we had one main job, all of us, it is to make darn sure that the far sound isn't far. So we have got to improve those amplifiers.
I don't know. At $22 for 1 3-minute call, I'm not sure the public is going to sort of jump over itself to call coast to coast.
Oh, don't you believe it. The way this country is growing, there'll be plenty of people who'll want to call. Once we get the cost down.
The problem is how.
Well, I know one way. Personally, I feel in the year 1915, it is a waste of our customers' money for 1 pair of wires to carry only 1 conversation.
We've been working on that carrier idea, but it's still a long way from being good enough.
Well, we've got to make it good enough. We'll need a carrier system that will send at least 5 conversations on 1 wire.
5 conversations on 1 line. Impossible? Not at all.
So that's how it happened. He felt he felt that they could do
3
5.
years
and
later,
so
in 1918,
That's so
5
funny.
individual conversations could be transmitted on one pair of wires with an improved carrier system.
yeah, so they it's kind of dumbed down and slow, but so they do that, and there's no real explanation of how these things happen. It seems to me the way that it's presented that it's just
As the years
a
passed, men
release.
sought ways to free the far sound from such distortion.
So it's like a release of information that is planned out, and I personally I feel as well about computers that it was done this way because of the way it just steadily improves. It seems almost like some of the technology was there ahead of time. The way that it is
Right.
always changing, and
Well,
you see it with this.
I can tell you, I can tell you how it was done, and it's really is not that difficult because, when I was doing this, when I was doing the microwave, many, many years ago, like 30 years ago, we were just starting to kind of make the transition from analog systems over to digital systems. And, the way that they were able to put 5 conversations on one pair of wires is they incorporated a technique called frequency division multiplexing.
Mm-hmm.
And essentially all that is they put a single carrier at a certain frequency, and let's just say they amplitude modulated it. It doesn't really matter what modulation technique they used, but then they would amplitude modulate that specific carrier wave, and it would have like about a 3 kilohertz bandwidth, right? So phone fidelity is not that great, or wasn't back that time. But
Mm-hmm.
then what you could do is on that same pair of wires is you put another carrier frequency that, of course, is far enough isolated from the original carrier frequency that you don't have any, harmonic or interference problems. And then, of course, you do the exact same thing. Then when they want to do another conversation, then what they do is they put on another carrier frequency, and then they will modulate that, let's say with amplitude modulation, or it could be frequency modulated, whatever. And they will then get another 3 kilohertz line out of that, and then they will do that again, and again. And now these days with frequency division multiplexing, which would be a good example, would be like the old cable TV systems before everything went digital, is they just took a wide spectrum of RF, and they had all these different carrier waves along that spectrum, and then of course they put the channels on there, both audio and video. Now what they do is they've kind of gotten away from the frequency division multiplexing, and with the advent of digital, they use what's called time division multiplexing. And what that is what you have all these different carrier waves, all these different signals, and then you have something that samples each one of them at a specific sample rate, say 44,000 samples per second. So it sweeps across and it samples all these different carriers, and then it goes back and it does it again and it does it again, and then they are all broken up. The digital signal is all broken up, into individual carriers. And then recombined back at the other end. So instead of using a difference in frequency, they're just using time and sampling, for
Mm-hmm.
digital. And that's how it's done today, which obviously is a lot more efficient and a lot more bandwidth efficient as well.
Mm-hmm.
So, and they can also dial in whatever amount of fidelity they want by changing the sample rate, whether they want it to be 14 kilohertz or 22 kilohertz or 44 kilohertz or whatever. The faster the sample rate, the better the fidelity you have on the digital signal, is the way that
Mm-hmm.
works. Conversely, on the old frequency division multiplexing, the more bandwidth you occupied, the better the fidelity of the signal. So that's
Mm-hmm.
how that was done. And,
Yeah.
there you
Yeah.
have it.
One question I have is to do that, you have to have your amplifiers in the line repeatedly. They call them repeaters. But with microwave, you don't have to do that. But with cable, you do, right? So with microwave, you only have to do that for every line of sight station. So
Well,
about every 100 kilometers or something like that.
yeah, exactly. About 100 kilometers, 60 miles, something like that. But again, what happens is because of the fact you are occupying, um, even with the digital signal, the more sampling you have, the more bandwidth it takes. So you may be occupying a spectrum that takes up, let's just say, 100 megahertz, right, in spectrum. Well, the only problem is that depending on the conditions, depending on the antenna resonance, stuff like that, you can get imbalances in the amplifiers that will, like, say, kind of slough off on the lower frequencies and have a little bit better performance at the higher frequencies. So you have to compensate for that so that the levels, kind of equalize out. So it's the same general principle either way. Like I said, you're using more bandwidth either way. It's just the methodology of sampling, one for digital and one for analog.
Okay, but I'll show you this this little bit about the cable
To the amplifier.
because it plays into the undersea
The very
cables.
tendency of the amplifier to
Okay.
distort
And
now produced a signal that was almost distortion-free.
Hello?
so they invented
The
this
feedback principle
um,
worked with so
in the
many voices at
1900s.
once that more conversations than ever before could now be carried clearly on a single line. But still, beyond a certain limit, are no farther.
Oh. Wonder what's going on.
But scientists and engineers have a way of confounding nature in their struggle to bring the far sound near. They conceived the idea of enclosing a single wire inside a copper tube to provide a protective pathway for conversations. This was coaxial cable.
So they're saying, I don't know if you can hear me now.
Yeah, I hear you. I hear you fine.
Okay. Yeah, so they invented coaxial cable here, they're saying, in the 1900s. But in 1854, I think it was, they laid the first coaxial cable transatlantic.
Oh.
And yeah, can you believe that? And
yeah.
And already in the late 1800s, or even, I think it was the first one that actually worked, which was they started laying it in like 1854, and it was operational in like 1856 or 58 for transatlantic communications by telegraph, supposedly. Okay, and so I looked into why. The pathway didn't make sense. It was a flat Earth proof, and so what happened? They have a explanation that there were so many cables laid on the actual straightest path that they couldn't use that. So the narrative, it really breaks down, and I'll go to this other video. There's more here. So they're talking about like laying the wires, and already they start to mention the microwave signal broadcasting. They were talking about the early transatlantic cables, and they mentioned the fact that for spans on land, you would think if you're doing an undersea cable, you'd think you could do the undersea cable on land, right? But they don't. They used microwave, and it went way back in time, and they didn't say when it began. And we're talking, 19, at least, it had to be, I think it was the late 1920s. They were showing it, and it looked kind of old. And so I wondered, when did they really start with the microwave? And so you see it throughout these presentations, whether it's on land or the undersea cable, there are spans of it where they're using microwave, okay? And so these things have been around, these towers just like this. And I started going back, and I just can't find the beginning of this. And so the microwave communication towers like this, they were around since I don't know when. And so they were talked about even with some of the early telephone lines, and even telegraph, I believe. Even telegraph, they mention or show a little bit about it. And so I just kept digging into it, and what I found is just all kinds of hokey explanations for how things were done. The timelines don't make sense, and it may just be that to carry multiple conversations at once is really the technology, but the long distance communication was already there, in my opinion. And they talk about laying down the lines, and like this guy is an expert. He's with AT&T, and he's talking about the first lines being laid.
In 1956, AT&T laid the first transoceanic cable called TAT-1.
Yet he seems unaware of the official history that says that what he's describing had already happened decades and decades before, in the 1800s actually.
But the only ship suitable for such long distances was the British cable ship Monarch. So the company designed the first truly modern cable ship, the CS Longlines. It was launched in 1961, and by 1963 had made its maiden voyage, laying the third transatlantic cable, TAT-3. On its next journey, the ship laid TPC-1, the very first trans-Pacific cable. That run is documented in this film.
Cable number 3 is ready for service. We have 2 order circuits patched in and working perfectly.
Wonderful, Wiedemann. That's what we've been waiting for. Thank you very much.
You can get some sleep now. Cheerio.
You know, I think we'll do that. Thank you again. Good night. Well, that sure works. Yeah.
2 people talking via ship-to-shore radio telephone. One on the high seas and the other on the Cornish coast of Great Britain. It sounds commonplace, and as a matter of fact, it is.
And so there are these red flags and signs of something going on that is strange about it. And
yeah, it's kind of right up there with the idea that we have to overcome things like the Van Allen belts, and somehow the engineer that's talking about that seems to have forgotten we overcame them 50 years ago, right? It's a recurring theme.
It's exactly like that, right?
2 people talking via ship-to-shore radio telephone. One on the high seas and the other on the Cornish coast of Great Britain. It sounds commonplace, and as a matter of fact, it is. But behind this particular conversation is a fascinating story. The construction of a worldwide network of undersea telephone cables. I am Lowell Wingert, a vice president of the American Telephone and Telegraph Company. And my job involves me in the continuously unfolding drama of international communications. In the continuously unfolding drama of international communications. The incident you have just seen took place in September 1963 aboard the Bell Systems Ocean Cable Layer, CS Longlines. Only a few minutes before, engineers aboard ship had completed the final splice of a third transatlantic telephone cable. Then came the radio telephone call confirming completion of still another communications route between the United States and England. It was an historic moment, and one that has been repeated a number of times on the CS Longlines. A ship that has played an important role in expanding communications throughout the world. This is her story, the story of a ship.
And it's bizarre because in my professional experience, if you make a mistake like that, somebody will call you out because they can get your job. If you leave yourself open like that, you cannot make a mistake like that. Maybe once you get a free pass, but a huge mistake like that, they'll question your intelligence or your memory, because something's or your honesty, and so the only real explanation for me would be that it's the honesty factor. Yet I find it hard to believe that these people are aware that they're lying. It's strange. I'll just put it that way. It's just bizarre to see this type of stuff. And then they have this. Oh, go ahead.
I was going to say, people don't pay attention to that, though. I mean, very few people. Most of the time when they're listening to stuff like this, they're in a suspended state of disbelief anyway, right? So they're not critically analyzing what they're hearing. They're just kind of taking it in because they figure, well, this isn't something I need to fact check.
And long lines was the ship for the job. On one early test of the new technology, technicians hauled up the cable after they found a short in the system and discovered shark teeth embedded in the cable. Turns out the unshielded fiber optic cable caused an electrical field that drove the sharks into a feeding frenzy. There are just some things you can't test for in the lab.
Therefore, they just let it go in. And unfortunately, that becomes embedded in their mind as like, well, what he just said was true, regardless of the fact it's already been, performed before or done whatever.
In 1956, AT&T laid the first transoceanic cable. But the only ship suitable for such long distances was the British cable ship Monarch.
And, I think they rely on that a lot. That's the whole formula for television as it is. But, they really don't care that, they get details like that wrong because most people aren't paying attention. Save the occasional weirdo like you, right?
Right.
So.
Yeah. Yeah, and it's bizarre. I still find it bizarre because, this is an industry video, and then the question is, who are they presenting to and why? And I'll just play a little bit of it. Hopefully it doesn't drop out. I'll just play a little bit here.
Cable number 3 is ready for service. We have 2 order circuits patched in and working perfectly.
Wonderful, Wiedemann. That's what we've been waiting for. Thank you very much.
You can get some sleep now. Cheerio.
I think we'll do that. Thank you again. Good night. Well, that she works. Yeah.
November 1963. Once again, the Bell Systems ocean cable layer CS Long Lines moves up Chesapeake Bay toward Baltimore. She is returning with pride after her first big job, a third transatlantic telephone cable. This latest voice route to Europe extends 3,500 miles along the ocean floor, from the beaches of New Jersey to the coast of Cornwall on the southwestern tip of England. The manufacturing plant is our starting point for this fascinating project. Undersea's cable, designed by the Bell Telephone Laboratories, is manufactured not only at the Western Electric plant in Baltimore, but also at 2 other identical cable plants, one in Southampton, England, and the other in Yokohama, Japan. Cable at all 3 plants is made to Bell System design specifications. In the first step on the assembly line, 41 fine steel wires are wrapped together on a stranding machine to provide an inner core, which gives the cable its required tensile strength. Now an outer copper sheath, which serves as the second conductor of the coaxial cable, is shaped around the white polyethylene layer. Finally, a protective covering of black polyethylene is added, and the manufacturing process is complete. The finished cable is 1 1/4 inches in diameter. Its 5 separate layers each represent a distinct and precise manufacturing technique.
On one early test of the new technology, technicians hauled up the cable after they found a short in the system and discovered shark teeth embedded in the cable. Turns out the unshielded fiber optic cable caused an electrical field that drove the sharks into a feeding frenzy. There are just some things you can't test for in the lab. CS Long Lines completed laying TAT-8 in 1988. For another...
So they're saying that the fiber optic cables had an electrical field that drove the sharks crazy. It made the sharks bite the lines. Like, how would they know that? And then there's the video out there of a shark biting one of these lines. And to me, that's purposeful. Like, I'm questioning whether these lines are even used. And one of the reasons is I looked into how they do it over land, and a lot of times they'll use the microwave relays, and then but with sea, they lack the ability to go in and power the lines to boost them along the way. And so I just don't know how they push the electrical current through. You know what I'm saying? Like with the coaxials, with the telegraph, even they say they do a very low frequency and that type of thing. But later on, they're saying they're doing higher frequencies, and they have these repeaters along the way. They're not battery powered. I don't know where the energy is coming from to push like a Pacific cable that's unbelievably long, you know. And I'm not saying there's not an explanation. You know, there may be one that I don't understand, but I've been kind of looking at it and thinking about it, and I don't know how they can do it, really.
Well, the cables themselves are not just, you know, in other words, like if you have a fiber optic cable, it's not just glass that's in there. There's obviously some copper in there, because they also have to take along power to run the optical amplifiers to, you know, amplify those at specific repeater points, right? Mm-hmm. So it's not, the cable is a little more complex than, you know, just what they're saying. Mm-hmm. And, you know, if they're saying a single coax, there's I'm sure there's more than that. It's probably a bundle, and I have no idea how these things are conglomerated, but it only stands to reason that there would have to be, you know, provisions for that on that cable, you know, like fiber specifically to be able to power the amplifiers as well. And you can't run power over, you know, the fiber itself.
Right. So where's the power come from is the thing I'm wondering. I just know from experience, you just can't run, if you're on the lines on the ground, like when you're running electrical just in a house or a building, you can only run it so far, you know?
Yeah, exactly.
And there's no other way around it.
Yeah, you would think that, you know, if it's relatively low power or DC or anything like that, you know, even if it's AC, it would seem to me it would still have to have a fairly high voltage that it would be, you know, being transmitted at. And, you know, who knows what that can do as far as interfering, you know, making an electromagnetic field, interfering with those light cables. I'm sure it can be shielded, but I have no idea, you know, how it's being powered or, you know, what those sources are, because that just wasn't my area of expertise.
Yeah.
But
yeah, I just haven't found an answer. And then the bundle, the bundles they show look almost identical to what they were laying in the mid to 1800s, in the 1850s. The very first one looks like what they were laying right up until recently in the 80s.
Yeah,
1980s.
Well, one thing we know is that, you know, as far as accuracy of what it is, they don't really care too much about that, because they know that the people watching it are not, you know, oh, look, that's a TX4926/R cable, you know. They're not going to be looking at that. It's like, oh, okay, there's a cable, they're putting it in, and, you know, so it's more, you know, more of a generalization for the demonstration, I think, than trying to be specific about anything, and they don't really care, you know.
Mm-hmm. Yeah, but it has me wondering if the cables are even what they say they are, because they're showing you about, the main point is, I think, because they're showing you the reality of it, I question the reality of it, and I think that they were using radio, probably microwave relays, to communicate.
So we found a bunch of huge sci-fi satellite dish things on the top of a mountain in Alaska, and they look like this. And we just figured out why they're there and what they do, and it's really weird. Hey everyone, Amy here. Our friends at Seeker went on a shoot to Alaska recently, and they came back with a story that we just had to tell on D News. It's about a huge, ambitious military project called White Alice. By now, the whole thing is barely a footnote in the history of the Cold War, but 60 years ago, it was revolutionary for the military, and for Alaska. In order to get why White Alice was so important, you have to understand a few things about Alaska. First, it's huge, it's empty, and it's wild. In the mid-1950s, it was home to just 215,000 people spread across an area that's twice the size of Texas. That made modern communication a pretty big hassle. Stringing telegraph or phone lines between cities meant crossing hundreds of miles of rugged, usually frozen terrain. The huge distances made radio communication flaky. Even high-frequency signals fritzed out when the northern lights appeared. This was all a big problem because during the Cold War, the US military needed good comm networks in Alaska. Pearl Harbor was still fresh in everyone's mind, and the government feared a far north sneak attack from the Soviets. Alaska and Russia are only 53 miles apart at the Bering Strait. It's such a narrow divide that the region became known as the Ice Curtain. The US and Canadian Air Forces set up a series of radar listening posts along the Arctic Ocean, but they needed a way to relay information across the state, and fast. And that is where White Alice came in. Beginning in 1955, the Air Force and Army built a network of communications hubs that used a very new technology to connect with one another. Phone calls and other data were transmitted via microwaves, beamed up into the air, bounced off the Earth's atmosphere, and back down to a receiving site. Each hub had two sets of dishes, one set for receiving a signal and another for broadcasting it back out to the next hub. The process, called tropospheric scattering, had, and still has, a lot of advantages over other technologies. First, bouncing signals off the atmosphere means that hubs don't need a clear line of sight to communicate, which is a useful thing in a mountainous place like Alaska. This way, White Alice sites could be 200 miles apart. The signal could also support multiple phone calls at the same time, something few other systems could manage. And, crucially for the military, it was secure. Once a signal is beamed out, it can only be received at one exact spot. They built 22 tropospheric scattering sites across Alaska, eventually spending around $300 million. And it wasn't alone. Similar networks sprung up all around the world. The US even connected Hawaii to the Philippines through the Pacific Scatter system. But it might have had the biggest impact on Alaska, uniting the new state in ways no other technology could have. But before White Alice was even complete, a new technology arrived to replace it. In 1957, the Soviets launched Sputnik, the world's first artificial satellite. US development of satellite communications picked up, and by 1967, just 8 years after the network's completion, the government began to divest from the very system it built. Interestingly, White Alice remained in use until the late 70s as a civilian phone network, because they're still really secure. But this remains the era of satellites. Now, the reason we have all this footage is that the White Alice hub outside of Nome still stands today. It's one of the last troposcattering sites in Alaska to escape demolition. The electronics there are long dead, but the structures themselves still serve a final purpose. They're unmistakable landmarks, visible for miles. And they still help hunters and travelers out on the tundra find their way home to Nome. Like I mentioned earlier, this story came out of a much larger trip to the Bering Strait, and the Seeker Daily team has a great video about how the whole world might need the strait soon.
It's huge. It's changing the world. Or you open up the Bering Strait to see what will happen, it's going to be phenomenal.
And as always, thanks for watching.
There are 15 long-range radar sites in Alaska stretching from Kaktovik on the north slope all the way down to Shemya in the Aleutian chain, and they actually fit within a portfolio of 21 full sites for Alaska and the Pacific that go all the way down to Wake Island.
All in all, the military built 22 tropospheric scattering sites across Alaska. Networks sprung up all around the world. The US even connected Hawaii to the Philippines through the Pacific Scatter system. But it might have had the biggest impact on Alaska, uniting the new state in ways no other technology could have. But before White Alice was even complete, a new technology arrived to replace it.
Which is constituted by two domes, one protecting all the heavy equipment that they need to keep the roads cleared and do a lot of the site maintenance, and then another dome which is where people live, for contractors who live there year-round.
Even if there's just the four of us here, we're doing somebody's doing something all the time. This is probably more of a working site than some of the others, but yeah, we stay pretty busy here.
from the two domes down at the lower camp, you take a really winding road that I don't know if we were lucky because we couldn't see how high it was and how precarious the road was. I just remember a lot of sharp turning and a lot of wheels spinning and digging into the earth, and the contractors we were with seeming pretty unfazed by it. You've literally got this old tram car system that's sort of built into a mountain that's defunct now and just sitting there beneath kind of like a metal box looking very bare bones. And yet at the same time you have what looks like a golf ball protecting a highly sophisticated piece of machinery that's collecting pulse signals, going 250 miles out in every direction. Inside, there's this very old worn wood because the site has been there since I think 1952 or 53 when it was originally built. And yet you've also got these kind of boxes and satellite displays and new processors that are, top of the line. So at once they're top secret and we couldn't bring cameras in, we couldn't take pictures, but at the same time, the function and the utility of these sites, that's kind of an open, I wouldn't even say that's secret, I would say that's kind of a broadcast. So they were built where they are, in part because of the highly remote locations. They weren't easily accessible, you couldn't know what was going on. Today, I mean, they're secret in the sense that they don't want the specifics of the equipment to be known, but they very much, I would say the Air Force is interested in the function of this defense system sort of being understood.
And other types of, and other parts of the spectrum, electromagnetic spectrum, especially the lower frequencies. Mm-hmm. And so they may have a worldwide broadcast ability that can be received and used to send data, voice, whatever, and it may have been around for as long as time. So here they talk about the history, and it's just kind of ridiculous. All right, so these lines, I saw so many different videos of how they make these lines. They look about the same. They have the same sheaths. It's almost the same equipment. And sometimes they're being made in Japan, sometimes they're being made in Europe, sometimes in the United States. And every time they present it, it's as if it's new. Okay? Mm-hmm. And so then they have this historical presentation, this History Society.
The event took place in New York. Our very own Martin Wark brings us this special report.
Hello, I'm here at the New York Historical Society to commemorate the 150th anniversary of the deployment of the world's first subsea cable between the United Kingdom and the United States. At the Hibernia Atlantic reception, I spoke to two eminent academics, both of whom have a strong interest in telecoms, and I asked them to put the pioneering project into its historical context.
Cyrus Field in New York had a vision. His brother introduced him to a telegraph engineer who had failed to put a line across Newfoundland. The idea there being that the ships coming across the Atlantic would call at Newfoundland, pass on their news, it would be telegraphed by landline down to New York, giving a 3 or 4 day jump on the news. So the line across Newfoundland was the first step. Cyrus looked at his globe, which was in his study, and said, well, if we're going to cross Newfoundland and come to New York, why don't we continue to Ireland? And from then on, from 1854 until 1866, 12 years, he devoted himself full time. All his finances, all his energy, all his friends' money that he could persuade to part with, went into the Atlantic Cable project.
Cyrus Field, of course, made...
So I can give you a little background. So they're describing how that first transatlantic cable came about, and it came about from the failure of trying to connect to Newfoundland. And,
wow.
Yeah, and so they, from that failure, they invested in going transatlantic, and it doesn't make sense at all. It wasn't technology driven; it was decision driven by a businessman. So he doesn't have the technology. He decides that if he invests in it, it'll work, which is not how business works, or how, and so.
Cyrus Field, of course, made his first millions in other industrial areas, and once he got going with the idea of the cable, I think his imagination was seized by the vision of worldwide communications. There was a scientific debate that centered around how to make the cable work. Here you would have the young William Thomson, who would later be known as Sir William Thomson, and eventually become known as Lord Kelvin, one and the same person all the way through, but it would ultimately take this man to figure out the mathematics behind how signals went the great distance, 2.5 miles below the surface of the ocean, 2,700 miles from Ireland to Newfoundland, distances never traversed by underwater telegraphy before 1858.
Barney Thorvald-Arson, the CEO of Hibernia Atlantic, delivered the keynote address.
So it doesn't work, and a guy who's an aristocrat figures it out as they're going along, laying the cable, basically.
That's crazy.
That's what they're saying.
That's freaking crazy. That is either the craziest, most irresponsible business model ever, or it's just a load of horse shit. And I think it's probably the latter.
Yeah. And so they present this. This is straight from the New York Historical Society in conjunction with London to celebrate this event. And these historians are here talking about how it happened, and they're doing it with a straight face even. I don't see duper's delight. And they're talking about how it happened, and it's an absolutely ludicrous narrative as far as I'm concerned. And yeah, so I'll just play some more because it keeps going.
At the Transatlantic 150 reception, and afterwards I asked him about the Victorian technological tour de force that changed the world.
Thinking back 150 years and about the group of gentlemen that took on the daunting task of laying a cable 3,000 or 4,000 kilometers across the ocean, across the Atlantic, where the longest cable then had been laid 20 kilometers between England and France. It was absolutely a fantastic breakthrough and a major breakthrough.
You know, 150 years of technology back then, 7 strands of copper wrapped together to do telegraph at about, 100 words per several hours and minutes. Now, with the new cables of the world, you can put the whole Library of Congress through in 63 milliseconds across the pond.
So what he just showed there, holding in his hand, is not the cable that the Smithsonian has. It's different. What he's holding in his hand is false, I believe. It's much smaller, and it's about, I'd say, half the diameter, maybe less than half the diameter of the cable that they say was the original one when it's presented on a different program from the Smithsonian historian.
Yeah.
So the historians aren't. Yeah.
The cable was in diameter about a couple of centimeters, or not even, with copper in the center carrying the electricity, carrying the signal. It absolutely was an unproven technology.
We're talking about something so historic. Don't really think that people get the grasp of it until they're actually here and really have been in this industry to really understand what happened 150 years ago.
So there's that statement. I mean, it's provably false. I just found it kind of funny. And let's see this. So in all these things, they're showing.
This is Fred Chappell in London. On behalf of the men and women of the Bell system, my thanks to both of you and all of your associates. Tonight, we have seen 2 great countries move closer to one another. And by your partnership and cooperation, we've created a powerful instrument for worldwide conversation and understanding between people everywhere. It's been a great pleasure.
And these chairs caught my attention. I don't know.
The sonic
something about them
all over them.
Yep. Yeah.
To participate in this occasion, I now declare the cable officially open for service between the United States and
Japan.
Then
they showed one of those phony flagpoles which were antennas, and all the old photographs, the antennas that they had everywhere.
She had the mechanical dexterity to handle the switching process.
I'm sorry, sir. The Boston lines are all busy.
And she had logic to select another route if no line was available.
Perhaps I can connect you through Hartford. Hartford, get me Boston, Parkway 32.
Memory, logic, and mechanical dexterity. Hear the heart of the Bell solar battery. Prominent in plans for satellite communications, goes into an oven for treatment. Two heads are apparently better than one for telephone research in the science of sound. This experiment reveals how people are able to locate the direction of sound. The equipment in this huge echoless chamber, including microphones in the dummy's head, permits acoustic scientists to influence the girl's hearing of test sounds.
Good night, and my very best wishes to everyone who has participated.
So yeah, I think it's around 1960, but it just gives you an idea. I didn't get the exact year, but I thought it was funny too. This map that they show. We're always told that it curves to the north in the northern latitudes, right? And they show it going south. They always do this with these cables, you know. Mm-hmm. And so there's something to that I keep coming across, because when you trace the path of the cables, it does not make sense, and their explanations make even less sense. You know, we had to avoid, you know, early on in the 1800s already, they had to avoid all these dozens and dozens of cables that had already been laid. I mean, you're talking about a vast ocean, and you're laying a cable. You could already have cables there. Well, they said, well, if they have to dredge it back up, if they dropped it, which they don't really, I think it only happened once, and they have to dredge it back up, you know, they said they couldn't lay it anywhere near other cables because it would make it harder, which wouldn't anyway. But yeah, so you have that. There's all these elements I keep coming up.
Tests ensure that all repeaters and cable sections are working satisfactorily, and that transmission performance measures up to engineered standards. Careful check is maintained on the power supplied to the repeaters aboard ship and those on the ocean bottom. 5,000 volts are required to operate the vacuum tubes in all the repeaters along the route. Telephone circuits are established over the cable so that the ship may maintain communication with the shore terminal and coordinate all tests and operations. And so the job goes on, with technicians and ship's crew performing the numerous tasks required to keep the cable laying operation in motion. At Midway Island, the cable is brought ashore to provide communications to this Pacific outpost. The rough coral reefs surrounding Midway and other Pacific islands can sometimes damage even heavily armored cable. This armor casing is extended out over the reef to a depth of 100 feet or more, where the cable plunges over the coral cliff toward the ocean bottom, nearly 3 miles below. From Midway, the long lines continues along her route to a point 700 miles west and the end of her 2,000-mile load of deep-sea cable.
Coming across. And so what it leads to, microwave, every time they kind of mention it a little bit. And so you have this graphic is that you'll appreciate this graphic here.
Mr. R.A. Dunbar at the Hotel Oxford in Birmingham, England, please.
This is modern communication, nerve system of the world, spanning oceans as easily as it covers the miles from farmhouse to town. Yet without an unimpressive-looking little body.
So then they show this, which is outside of the communication hub, right? Mm-hmm. But I've seen these a lot in these old photos from the 1850s, you know, 50s and 60s.
of magic. We call it simply the electron tube. There would be no communications as we know them today. The electron tube had its practical beginning in this humble laboratory, where a young man named Lee DeForest worked in lonely isolation. But the history of all the scientific achievement which preceded DeForest's work would be as difficult to trace as to uncover every withered root of a 2,000-year-old redwood tree. Suffice it to say, then,
So I think there is truth in plain sight. They're saying that this thing that they're referring to as the electron tube, right, that's been around probably closer to 2,000 years. That's what I take out of it, because the words aren't randomly chosen, and the evidence keeps pointing to it.
Right. Well, they also call them vacuum tubes, and they found things that they called light bulbs that essentially could have been, akin to a vacuum tube, back in the Egyptian times. I think they even found it in some of those tombs. So yeah, it's possible.
Right. And there are accounts of these things being operational when they first encounter them. And then they don't even know how it works, but it's just like a glass ball or something that's lit. When they walk in the room, it's like automatic lighting. Have you heard of these accounts?
That's new.
Okay. Yeah. I wish I could cite the source. But yeah, there are these early accounts of these people exploring into these underground so-called tombs, and they walk in and it's like gradually lit, like you would have it be in a expensive home or a modern, or like a video game or something like that, where it's just when you want it to light, and it comes up gradually and lights up, and they didn't know how it worked, and then it just lasted for a while, and then it just turns off, and then it can't be turned on again. Yeah, one of them I got from I saw from watching Martin's show. It was written about in one of these old manuscript type documents with like the woodcut illustrations and things like that. Very old,
Interesting.
The flow of vacuum. Edison and DeForest in the United States, Fleming in England.
So you have Edison, I know, is complete hoax, basically a character, and then you have this DeForest guy, and then you have Fleming over in England, and the name Fleming is pretty well associated with spies and everything. You have the Ian Fleming, and his brother wrote a book about exploring, I think it was Tartaria too, as well. But yeah, and so okay, it just keeps adding up. It's the preponderance of evidence.
Right.
I don't know how chemistry plays into this, but they have this like lab and showing how the vacuum tube is made, right? And they award the Nobel Prize. I could go really deep into this guy. Somebody sent me information about him. It absolutely proves, beyond a shadow of a doubt, even his education was inconsistent. Like what school he went to, I think was either the school hadn't actually been created yet, or it was created while he was going there, and then the years he attended were different, and then it overlapped with time spent elsewhere. And of course, he went into the military, like a lot of these people do, and all of a sudden they're PhDs. All of a sudden they're inventing these things. Okay, so you've got so the history's got that aspect of it, and of course, you've covered this a lot about the microwaves, the line of sight, and it either follows the Earth's surface as ground waves, or it reflects on the ionosphere. That story, and
yeah, it's like whatever.
Right, and so this was a little interesting scene where they're showing this, and I don't know if it's like the actual city at the time. If it looks like that, it kind of seems like a studio set, but just take a look at this.
The time DeForest was experimenting with his Audion, a long-distance telephone call of a couple of 100 miles required a healthy pair of lungs.
Hello? Oh, all right, put him on. It's a long distance, please. You better close that door. And the window. Hello? What? Yes? Oh?
So it's like a comedic drama, you know. Why do they feel the need to do it? You know, it's totally suspicious, right?
Yeah, it's bizarre.
So this is just pretty interesting because, again, there's no reason for them to do this. But these towers, I think they had been around for a long time. And there were a lot of towers like this throughout the country that are maybe looking a little bit different, maybe not as tall as these, but they were around. And it's pretty simple to get these things working. And this was the ham radio. Yeah. So yeah, that was neat to see that. And oh, that's Periscope Films. I got to edit that out. Shoot. So this is the last thing I wanted to show you. The first telegraph, the first telegraph line that ran underwater, they said, was run between England and France. So you have the cliffs of Dover, which overlook the channel. So they unearthed these things they call acoustic mirrors, but to me they kind of look like they could have been used as for microwave communication.
Yeah, big parabolic dish for something.
Yeah, these things are all over the place. There's no history on it. They were just found, unearthed at the cliffs of Dover, so it's obviously, I think it's facing France. And they say, oh, well, that's to detect the approach of enemy aircraft. And maybe that's true. And maybe this isn't really what was found, but you know how they kind of cover things up with the cover story. But there are a lot of pictures I found. Those things are all over the place. They're as old as time, it seems like. And so what I think is when we see these older photos with these towers on almost every single building and the very old photos that aren't really explained, they kind of say that they're flag poles, or they have different explanations for those things. I don't think so. I really don't think that they are flag poles or lightning rods or cranes, but they were antennas, and they're exactly the right size to do shortwave, to do like ham radio. They would work with CB radio. They're also appropriate, I think, for certain sections of the microwave frequency band. And then there are other bands that are basically off limits to everybody. I think they would also work for. And you combine that with the atmospheric energy, and also combine it with this use of the crystal radios. And if you know about those are just self-powered. They just use the ambient energy to function, and it's not very loud, but
they
under
work,
certain circumstances,
piezoelectric crystals.
Yeah,
exactly.
And with headphones, it'll work. And so I think that the old world communicated that way. And,
I agree, because those big towers they don't have to be specifically set for one frequency. They can be, you can either have an antenna as a fraction of a wavelength for a specific frequency, or multiple of a wavelength for a specific frequency. So really they can be used for multiple different frequencies.
Right. And so I think they did that. Some of them looked to be adjustable, and then some of them were hooked up with equipment that includes like dials, and they look really rudimentary, and they are, but that's the beauty of it, is that it's sustainable. It's an elegant design. It's not a complex electrical mechanical contraption. It's actually very elegant, and I think it would work in probably the frequencies that are banned. Do you know what I mean? Like, is it the G band? The government has certain frequencies blocked off.
Yeah,
and some of them they use, and some of them they don't.
That's right. They're allocated for certain things, and you know, just like anything else, you have your spectrum of use for whatever service you're using it for, and some spectrums are just absolutely off limit.
Right, and so I wonder if someone did pirate broadcast in some of those frequencies, if you wouldn't hear that broadcast coming through certain objects, like in these older buildings that they're tearing down. They may be perfect for receiving these certain frequencies, and I've even gone so far looking back through some of these chandeliers and things that have features on them, crystals and different things that could possibly have been used as a speaker or like a loudspeaker, you know, because of resonance. It would work theoretically, and it's just an idea maybe that could be looked into. But I just found it all so fascinating, and I'm almost completely certain that what they presented isn't the case. And I think it is important to know, you know, if there are people out there who do investigate this, that maybe there's a way of communication. I guess it didn't really help the old world avoid destruction, but it's a tool, you know, it's a tool to have. So, and it's free. It's free once you know how to do it. The crystal radios actually can be built by hand pretty simply, and they don't even require power.
I think that once all this information, you know, finally does come out, you know, this whole end time revelation of everything being revealed, it'll be just in time for the next reset or whatever, and we'll never really actually get to utilize it. Is, you know, what I'm thinking, which sucks, but that's, you know, to me it just seems like that's the way it's going. Right.
Yeah, I have these moments of like, oh man, I hope I'm not helping all this along faster by just trying to find out truth. But,
I've thought that so many times. You know, I've even said it on Globebusters. It's like, you know, we're by revealing all this stuff and showing all their hoaxerism and you know, exposing them at every level, are we really hastening our own demise? You know, you got to wonder.
Well, I don't think that they're all powerful. That's the thing. I mean, I think it gets to be this way when they start to run out of the superiority, you know, the knowledge and the resources.
Well, as long as they have control of people's minds, they're pretty powerful. And right now, it looks like they're pretty much in control of most people's minds, and that's the scary part.
It is. It's terrifying. But, yep. So, well, okay, yeah. And on that note, I think it's important to enjoy life and make the most of it, however it is.
Absolutely.
Yeah, and I'm not going out much, but when I do, I just behave normally, and if people don't like it, they don't like it. But hey, I don't want to exist any other way. So,
I hear you.
Maybe a dry run, or maybe like the 1917, 1918 Spanish flu. I don't know. Knowing what's up is a lot better. No matter what. So.
Yeah, that's true.
Yeah. All right. Well, thanks for spending the time.
No problem.
Yeah, and it's great having you. And
in 2 days, and then we are out of here and going to North Carolina. So I mean, we're literally. And then once we get all settled back on the East Coast, then Globebusters will be back, and I will not be talking about anything other than flat Earth because, frankly, I'm sick of COVID and I'm sick of all this other BS, and I just want to do what we started the channel for, you know.
Mm-hmm. Yeah. I've tried many times to cut that subject out with moderate success. Yeah, but
Yeah,
it has a way
hard.
of draining. Yeah, it's just got a way of like, it's amazing. It's just an incredible thing, really. I mean, it's like supernatural. I'm bearing witness to something supernatural, but yeah. But anyway,
without a doubt.
All
right.
Yep. So, okay, well, I'm glad I could provide you a break, at least during the day, excuse to take it easy for a little bit there, but I'll let you get back to it. So I want to thank you again, Bob, and good luck with the move, and we'll catch you on the flip side, and I guess you'll be on my side of the country here. So
you betcha. You're very welcome.
Welcome you to this side of the Mississippi.
Yeehaw! All right, man. You take care.
All right, take care.
Okay, bye-bye.
Bye now.